Okay, this is a general science course, and as such, the first thing I want you to understand is the scientific method. In your book, the definition of the scientific method is an organized approach to explaining observed facts, with a model of nature that must be tested, and then modified or discarded if it fails to pass the test. So let's take that apart. What are observed facts? Anyone?
I'll try.
Okay.
Okay.
Isn't a fact
Isn't a fact
a
according to this
statement that everyone agrees on?
result?
So you'd say that a fact is
that a fact is
objectively true.
objectively true.
Yeah, that's what I mean.
That's what I mean.
Okay, that sounds good.
Okay, that's
But what about this?
What about
We
this?
consider it a fact that the sun rises each morning and the earth
the
rotates.
Earth rotates.
But facts like that aren't always agreed upon. Look, when we say that the sun rises each morning, we assume the same sun day after day, an idea that might not have been accepted by Egyptians, whose mythology taught them that the sun died with every sunset and was reborn with every sunrise. Now, let's consider
Now let's
the case of
consider
the
the
Earth's
case of the
rotation.
Earth's
Well,
rotation.
for
Well,
most
for
of
the
human
most of human
the Earth
history,
was
the Earth
assumed to
was
be
assumed to
stationary
be
at
the
the center of
station
the
of
universe.
the center of the
So, as you
universe.
can
So,
see,
as
our
you can see,
interpretations of facts
facts
often are based
are
on
based
beliefs
on
about the world that others might not share. Still, facts are the raw material that scientific models use to explain. So it's important that scientists agree on the facts. How can we do that?
How can we
How
do
about
that?
this?
How about
A
this?
fact has to be
has to
verified.
verify.
I mean, that's
I
where
mean
testing
that
comes in.
testing
So
comes
we
in. So
have to be able
we
to
have
test
to
the
be able
model,
to test
but
the
we
model.
have to be able to
But
test
we
the
have
fact
to be able
too,
to test
right?
the fact too.
Now
right?
you're on the
Now
right
you're on the right
In the
track.
context
In
of
the
science,
context
a
of
fact
science,
must
I
therefore
found
be
about
something that
therefore be
anyone
something
can
that
verify
anyone
for
verify
himself
and
or herself,
themselves
at least in principle.
in
So,
principle.
even though the
Even though the
interpretation may be different,
interpretation
some
may be different,
interpretation
some
of the sun
interpretation of the
is there
sun is
every
there
morning,
every morning.
and that can be
And
verified.
that can be verified.
Then a model
Then a model
is
is
explain the
proposed to
facts,
explain the facts.
and the model
And the model is
An explanation of the facts.
an explanation
Right.
of the facts.
Once the facts
Once
have
the
been observed,
facts
a model can be proposed to explain them and not only explain what's
what
obvious,
is obvious,
but also make
but also
predictions
make
that can be
predictions that
tested
can be
through
tested
further
through
observations or experiments.
or experiments.
Let's go back to
Let's
Ptolemy's
go
model
back
of the
to
universe,
for the
which
model of
assumed
the
that the
universe,
Earth
which
was the center of everything.
center of everything.
Okay,
Okay.
that was a
That was a
useful
useful
model
model
because
because
it
it
predicted
predicted the
future
future
location
location
of
of the sun,
moon, and planets
in the sky.
However,
However,
although the Ptolemaic model remained in use for nearly 1,500 years, eventually it became clear that its predictions didn't quite match actual observations. A key reason why the Earth-centered model of the universe finally was discarded. So models are discarded when they don't match the observations. Exactly. And new models are proposed to explain the facts in a better or more inclusive way. Okay, how does a model achieve the status of a theory?
Well, I guess sometimes the model doesn't fail. You know, it gets repeated by many experiments, and the predictions are verified.
So when a prediction is verified, repeated, then we start to assume that the model is a valid representation of nature. And when that happens, with many experiments and a number of different researchers, then the model achieves the status of a scientific theory. But
Yes, Jerry.
Well,
The
the
problem
problem
is that the
theories
theories get discarded too, don't they? Absolutely.
Because it isn't
Because
really
it is
possible
very
to prove
possible
that a
to
theory
prove
is
that the
true
theory is
beyond all shadow of a doubt. And that's good
And this
because
could because doubt is the
cornerstone
cornerstone of science.
Even a
Even
well-researched and presented
theory
theory
should
undergo
undergo
continuous
continuous
challenges
challenges
from the
of the
scientific
scientific
community, with
community,
further
with further
observation and
observation
experiment.
and experiments.
I'm sorry.
I'm sorry.
Did we mention the
Did
term
we mention the
hypothesis?
term
Does that fit in
hypothesis?
with the model or
Does
a
the
theory?
theory is a model or
Glad you
theory?
brought that up.
Glad you
A
brought that
proposed
up.
model is
The
often
proposed
called a
model is
hypothesis.
often called a
That
hypothesis,
just
and
means
that just means that scientist is making an educated guess that the model's prediction will bear up on the
So a
test.
hypothesis is a
So a
proposed model.
hypothesis is
Right.
a proposed model,
But
right?
let's put this
So
all
let's
together,
put
shall we?
this all
Step
together, shall
one
we?
is
Step one is
observation.
observation.
The collection of
The
data,
collection of
that
data,
is
that is
observation.
observations.
Step two
Step
is
two,
hypothesis,
hypothesis.
or a model to explain the facts and to make
and
predictions.
to make prediction.
Step 3,
Step 3, additional observation and experiments.
And here's the
And
important
here's
part.
important part.
When the predictions fail, then we
then
recognize
we
that the
recognize
model's
that the
flawed.
model is flawed,
And we have to revise or discard it.
discard.
When the
But
predictions are
when
verified
prediction
on a
are verified
consistent
and
basis,
consistent
then we
basis,
consider
then
the
we consider
possibility
the possibility
that
that
we
we
have
have
a
a
true
true
representation
representation
of
of the nature.
and we
And we
elevate
elevate
the
the
model
model to the status of a theory.
So step 4 is the
So
theory.
step 4 is the
Right.
theory.
But
Oh,
even
that's
then,
right.
the
Even
theory
then,
must
the theory
undergo
must
step
undergo
5.
step 5.
That's further
That's further
observation,
observation,
and
experiment, and challenge.
Okay, so far?
So far?
Okay.
Okay.
Now,
Now,
reality.
for reality.
In the real world of
In the real world,
discoveries are
discoveries are
rarely
rarely
made
made
by
by processes.
as mechanical
As a mechanical,
as
as
the
the idea, right? The
scientific
scientific method outlined in your
the
textbook.
one that we just summarized.
The ones that
For
can
example,
summarize. For
anyone
example,
recognize
anyone
the name
recognize
Johannes
the name
Kepler?
Johannes Kepler?
Sure. Didn't he
Sure,
propose
did
the
he
laws of
propose the
planetary
laws
motion?
of planetary
He
motion?
did in about
He did it in
1600.
over 1600.
But instead of verifying new predictions on the basis of his model,
the
he
model,
tested the
he
model
tested
against
the model
observations
against
that had been made previously. And like
and
most
like
scientific
most
discoveries,
scientific
Kepler's work
discoveries,
involved
Kepler's work involved
intuition,
collaboration, and
moments
others,
of
emotional
insight,
insight,
and luck.
and luck.
And eventually,
And
other
eventually,
scientists
other
made a
scientists
lot of
made a lot of
observations to
observation to
verify the
verify
planetary
the
position
planetary
predicted
position
by his
predicted
model.
by his model.
Then,
So
go ahead.
Go ahead.
So
So
the scientific method in the book,
that's
that's
not
not really
really
the way it happens a lot of the
a
time.
lot of the time.
Okay, let's put it this way.
Okay, let's put this way. The
scientific
scientific
method
method
is
is
a
a
process
process
that
that
we
we
need
need to keep in mind as we do the work of the scientist.
But we should
But we
also
should also
understand
understand
that it's an
that it's an
idealized
idealized
process
process
for
for
making
making
objective
objective
about
judgment
whether a
about
proposed
whether a
model
proposed
of
model
nature
or nature
is
is close to the truth.
And we should
And
also
we
keep
should
in
also
mind
keep in
that
mind
in the
that
work
in
of
the work of
scientists, other
scientists, other
factors are also brought to bear
brought to
on
bear
those
on
ideal
those ideal
steps in the
steps in the
process.
process.